Hello everyone, it's me again, Eduardo V. Meister. I'm doing a second course for Regulate related to artificial intelligence and risk management. This is one of two courses. The first one was related to risk assessment, and over there we cover the ethical concepts and how they were translated in trustworthy AI requirement to end as different tools that could be or approaches that can be used for assuring that the AI development is in a trustworthy process. Some of these things that we covered previously was the TAI tool, and it's not going to be covered over here. Over here, we're going to focus mainly on different approaches like the ISO 31000 and the RAS approach, and how can implement these approaches that already exist in different domains into artificial intelligence. Okay, so the things that we are going to be covered over here, we are going to have first an introduction that is going to talk about general concept of risk management and how that was linked to artificial intelligence ethical concepts. And then we are going to go to this specific risk management approach. We are going to cover both, but that doesn't mean that you have to go for a mixing of them or one specific. There's another approach that can be used depending on the user's domain, because these are linked to different standards or frameworks that exist. Then we are going to go to evaluate or show one tool that was developed in one of the European Commission projects that is within the cluster of ICT 38 projects. Specifically, this project is Assistant, and it developed a tool based on these two risk management framework. They merged and came with this tool that can be used not only for keeping track or as a risk management process, but it allows also the specification of certain KPI that can be used for measure the trustworthy state or the artificial intelligence components that are developed, used, or in the worst case that are not acceptable, the development or use, decommission it. So then let's go first with the introductory part for risk management. So the first thing that we are going to be talking is the differentiation when we talk about artificial intelligence with different mechanisms or artifacts that are already in use by humankind. When we talk about this normally component that use in order to being trusted by the user, we ask normally that they have to be robust and they have to be lawful. They have to be robust in the sense that they're going to be technical, sound, and it's going to be keeping constant or normally within a range their outputs given certain time of evaluation or certain time of processing. The other component, also robust, has to be in a societal perspective, because society could have some modifications of some trends, and therefore a component has to be robust to be able to be with small modifications, being able to update its functionalities, and being capable to keep state given the trends that exist in society. These two considerations, again, the lawful and robust, is specific for components that already can be used. But when we talk in artificial intelligence, since artificial intelligence has some capacities that are unique, that they can learn or that they can predict outputs that can be used for decision making, we have to come with another layer of consideration for the user to trust them. This aspect is one of the is ethics, and it's settled that if some outputs of the artificial intelligence are going to be impacting human decisions, we have to make sure that these outputs are sound based in some ethical components. Ethics, again, is a field of human evaluation and human analysis that look for what is supposed to be wrong or what is supposed to be right. So the idea is to develop the AI elements under the principles or different principles of ethics, and develop in the sound way that the decisions made by the AI and its users are going to be sound based on these regulations. So when we consider the trust, again, we have the lawful consideration, the ethical consideration, and the robust consideration. The ethical component was evaluated by the AI for People in 2018 and defined 5 principles that the artificial intelligence has to fulfill in order for the user to trust them. These principles are non-maleficence, beneficence, autonomy, justice, and explicability. I'm not going to go specifically on each one of them. They can be understood very easily in the sense of what is the wording, but not all of them were used by the European Commission in order to specify the trustworthy requirements. The trustworthy requirements only considered 4. It didn't consider the beneficence component, so it was worried more related to the non-maleficence, autonomy, justice, and explainability. By using these 4 principles, the European Commission came with the trustworthy AI requirements. There are several requirements, but in each of these requirements, there's a different specification of component that has to be fulfilled. So at the end, there's more than 7 considerations that has to be done, but it's important that not all the artificial intelligence components have to fulfill each one of the trustworthy, because there's some risk consideration that has to be taken in account when we are going to be defining the artificial intelligence functionality or the domain that they are implemented. So over here in this slide, you can see in a broader perspective how is that the ethics and risk consideration are connected. In fact, from the white paper of artificial intelligence, there's been a focus on considering the artificial intelligence risks one of the main points for considering the AI development. When we talk about risks, normally they can have different levels. Okay? And it's important to consider that they can have, at least the artificial intelligence component, can have several impacts or serious impact in the fundamental rights, in the safety, and the liability concerns. So these 3 kind of focuses are those that have to be considered in the requirement and are included in the trustworthy requirements, and they can be applied in a technical and non-technical way. This list has previously been described in another course that is related to the AI risk assessment. So I encourage you, if you want to just have a broader perspective, you can go over these other courses. Over here, we are going to focus again a little bit more in the risk management, so we are going to go a little bit further. When we talk further is that we have to understand the time frame of the things that have happened lately. First, approximately 8th of April 2019 was the definition of these trustworthy requirements, and after that definition of trustworthy requirement, in 2020 came the publication of the white paper on artificial intelligence. Over there was a wider spread of the knowledge and insight related to the risk considerations in artificial intelligence. And from there, in the 2021, was the release the Artificial Intelligence Act. In this last document, is specifying classification of the artificial intelligence depending on the domain that they are embedded or the functionalities that they are performing, okay? Now, so the latest documentation that we have right now is the Artificial Intelligence Act, and this gives us an idea of classifying the risk of artificial intelligence that has to be linked to the trustworthy requirements. As you see in the bottom of the slide, we have these 4 ethical principles that were translated into the trustworthy requirement, but there's still different mechanisms that this trustworthy requirement can be translated as a risk management process for the definitions of taking care of the elements depending on their risks level. Okay? So since we are going to be covering in this course everything related to risks management, first we have to have an understanding of the risk and what we are going to be defining as a risk in artificial intelligence. To do that, first we have to understand that The risk is a combination of a probability of an event and its consequences. Of course, we are more concerned about the negative consequences of hazards that can exist when managing artificial intelligence component. And therefore, we have to take care of principal focuses on those that are going to have higher impact on it. Okay? The other thing that we have to think is that the risk is going to happen once something materializes. And given that is that we can, depending on the activity of how it materializes or the probability that this effect happen, we can in some sort of way keep a track or measure what certain probabilistic terms, how risk is our situation, how risk is our development that we are performing in a specific AI asset. So we have to come from some definitions for the risk in the artificial intelligence. So for that, I know that you are presented with a slide that has several texts, but I recommend you to read it. This over here is the presentation of a risk definition for artificial intelligence based on a European Commission project. Specifically, this is the assistant project, and over there was a full analysis or the linkage between trustworthy AI requirements and the risk of Artificial Intelligence Act. It came up with some definition that is at the bottom of the screen that specify what is under this project ethical AI risk. Of course, depending on the functionality of the AI, there could be some slight modifications, but this presentation is going to be focusing on these two definitions. We feel we have a general perspective, and at the bottom, the definition of what is an ethical AI risk. Importantly, again, I want to specify a little bit about risk. That risk can be part of three different classifications. We have those that are recognized as hazards, those that are recognized as control risks, and those that are defined as speculative risk. The last one, speculative risk, is more related to banking because the outcome of it can be positive or negative. So normally is more related to a decision made by the user, and if that definitions can have different outcomes. We have also the control risk that is more related to have a condition for the system stable and how probable is going to have the system to be kept under that conditions. So the idea is of the system to keep it functioning in a certain range, and therefore give us a sensation of the noises effect that can have the inputs that can have different nature on the AI outcome. Finally, we have the hazards that are recognized as being negative, but one of the important considerations of the hazards is that they can be specified at tolerance level. So this tolerance level at the same time not only tell us how much we can go, but also tell us that we need a certain metrics in order to evaluate the possibility to go over this threshold. This threshold, of course, can have different consideration in the risk management. For example, we can tolerate, we can transfer the risk, we can terminate the applications, okay, depending on the risk levels that are involved. That, of course, is going to be defined as something named risk appetite. That's how much intention is desired or how much attention I have to put on the risk components that exist in our asset. The impact of the hazards can be different. For example, in the screen you are seeing 4 of them: disrupting normal operation, security and safety, increased cost, and pure publicity. Of course, there can be others, but this is something that is give you an idea of the impact that can have the hazards of artificial intelligence. Now let's jump to another topic, that is the approaches for risk management in artificial intelligence. So the first thing that we have to take considerations is normally when we're talking about risk, we have risk assessments and risk management. There is risk assessments as being covered previously in another course, and there are frameworks or standards can be used. As a supporting tool or framework also that can be recognized is the TAI tool that was previously covered into the courses over here on Regulate. But when we talk about management, it's a higher level that it has to be a continual process that embed all the different stakeholders and has to follow specific approaches or protocols in order to be performed. So when we talk about risk management over here, you're seeing in the screens the different characteristics of the risk management. So the idea of them is used for the creation and protection of values. These values is not the same perspective of what was covered before when we talk of ethics, morals, and values. These are the values that is required necessarily by the enterprise in order to have the desired outcome. Okay. Additionally, it improves the performance because it's constantly evaluating the system and it allows updating or modification of small changes in the system. For example, in artificial intelligence could allow incorporation of specific functionalities that could improve the system in general. So it's a constant process that is supposed to continue during the life cycle of the artificial intelligence. When we talk about life cycle of artificial intelligence, it's not only the development, deployment, and use, but we have to also have to consider the decommission of any component and how we are going to make sure that, for example, some data that was accumulated is kept or eliminated depending on regulation like the GDPR that exists. Finally, this risk management process is a stage-wise consideration, and over here in the screen you are seeing those two different approaches. So depend of they can have small modifications between each other, but normally the protocols that are functioning or are used follow some certain trends. These trends generally, for example, in the specific domain, in the manufacturing sector is the ISO 31000. The ISO 31000 is shown over there in the screens and is normally referenced as three main components that are linked within each other. We have the principles, the framework, and the process for itself. What you saw in the previous screen were the processes, where the principles and framework tend to talk about a little bit more at a higher level that, for example, the specification of the level of risk that you are going to be using, the analysis of the scope, how you are going to be implemented in a sound manner and in a timely manner. So there's different concepts for consider. Over here in the screen, you are seeing the principles. In the principles, you have to consider that has to be integrated. That means that once you deploy it, it can be merged to other activities. This is super important when you are going to develop a new framework that is going to be interacting in other domains. Therefore, you have to consider what is being used. For example, if we are going to go again to the manufacturing sector, it's considerably important that if they are using a specific tool, for example, the FMEAI, you can use similar tools in order to merge them and integrate it into the general system. Additional other concepts within the principles as the structure and comprehensive considerations. We have also that has to be customized. Customized is super important because it's going to be adaptable to the different domains. Each domain will have a different requirement and different functionalities will have different requirements. So depending on them, you have to come maybe with a different framework for the risk management of the assets. It has to be inclusive, so that's not much to say about that. That has to be include different knowledge, variety, and stakeholders, and this also have several different perspectives, especially in enterprises that you have different levels of interaction with artificial intelligence. It has to be dynamic, it has to have best available information. So not much to say about that you have the users of those that are going to be implementing any framework has to keep track of historical record, and also a good diagrams or good sound information that will be used to connect not only the risk with the asset, but also the impact that they have the asset in other systems that are connected to it. And it has to be human and cultural factors. Okay, this is great for us because if we are going to be considered ethical concept, of course, we are taking considerations of the human factors. And finally, as to have a continual improvement process, so we know that it's going to be a process that's going to be dynamic in time, and it will allow incorporation of modification in the systems as it's run. When we talk about the framework, I'm not going to go deeply into the slide, there's different considerations that we have to have. One is the integration, okay? That is one of the important things that risk should be managed in every part of the organization structure. So that means that has to be considered at a higher level, because if once you incorporate a risk management process, that means the structure of the enterprise can be modified to adapt this risk management process. It has to be designed, it has to be considered implementation, has to be considered to be evaluated, and it has to be considered improvement. This last one's improvement is considerable because you're not only improving the Artificial Intelligence Act, but you can also improve the framework by itself. That means that you can update the approaches that exist or the times that are being settled from the beginning in order to improve the performance of how the framework is implemented for the AI that are under evaluation. And finally, we have the process that is the last component of the ISO 31000 that is specified in a broader way the specific task that has to be performed. And as you've seen, this is an approach that is the risk management process under the ISO 31000. It's a continual process. Once you initiate it, you will follow different stages like an UML diagram, and it will allow you to perform the different actions. This framework is not necessarily the one that is going to be implemented, and it's not the one that we use for the project that we are going to be discussed later on. But it's important to consider that you can modify it a little bit, this structure, depending on the needs of the specific enterprise or the assets that is required a risk management process. When we talk about a little of another framework where we have the RASP approach. The RASP approach, or its letter, comes from, as you can see in the screen, the risk architecture that is related to how the information is going to be moving through the different stakeholders' involvement and define roles, responsibilities. We are also between this RASP, the risk strategy that's come for the S of RASP, that define the risk appetite or attitude toward these risks. Finally, we have the risk protocols that are defining, again, the mechanisms or tools that you are going to be implemented. Everything is encapsulated in the risk policy that is at a higher formal level of documentation of how it's going to be presented by the enterprise, the risk management process. And therefore, this could be linked in some sort of way directly for what the European Commission has established already. So we can link the requirements or definitions set by it, for example, when we talk about Industry 5.0, to the specific needs or considerations that are going to be in the policy document of the enterprise for starting the risk management process. Over here in this screen, you see a little bit more in detail what are the specific focuses of the RASP component. For example, in the risk management policies, how you see in the screen, we have the purpose, the scope, the governance, the management process, etc., etc., etc. I'm not going to go in detail for each one of them, so if you want, you can stop the screen and continue later on with the presentation. Let's go, after discussing a little bit of the risk management approaches, I want to talk a little bit about the trustworthy AI process for risk management that is called TAI PRM. This is a tool or a framework that was constructed for a specific project in the European Commission. This project is based on the manufacturing sector, and they involves the development of different AI tools in the different stages of the manufacturing sector. Specifically, it develops tools for the process planning, production planning, scheduling, and real time. The idea is to develop different digital twins of the real system, and based on this digital twin and artificial intelligence come with optimal configurations for each one of these processes. Over there in the screen you can see the link if you want to have further information. What was performed in this project is that first we stopped, or we beginning, depending on the way you see it, with the Artificial Intelligence Act. We know that in the Artificial Intelligence Act we have different classification of our components that can go from an acceptable risk level to a minimum on risk level or low risk level, depending on the functionalities that we want to have. So we merged this idea with both the risk approach, because we use the policies established in the Artificial Intelligence Act as the policies for the risk management process, but in generally the protocol for the RASP approach was followed by the ISO 31000. So this was produced as one of the deliverables of the project, and it's important that it states a process as a framework following a UML approach that it can be followed by different users. And at the same time, it produced different management metrics, so you can keep track of the different risks that you perceive on the Artificial Intelligence Act. And again, this at the same time in this deliverable is specified the management tool in a general perspective if you want to have further detail. This is a public access, so I will not go into further detail here. When we talk about the RASP approach, of course, first we have to specify a risk architecture that is going to be defined for the domain of implementation. When we're going to be the strategy, we have to focus in the fulfillment of the trustworthy AI requirement white paper and Artificial Intelligence Act, because we are going to be considering each of the risk level. And with the protocols, this is the important part, that is focused on something that has already been implemented in the domain. It's not only in the manufacturing sector that these tools are used, have been used in different domains, but the FMEI approach or FMEI-CA are well-known and documented approaches for risk management. This is a technical also failure mode analysis that if it focuses in the analysis of a general failing conditions that can have the AI sets, and by identifying which are these failures mode, you will have a sensation of what risk you should have, and at the same time you are supposed to be managing. So in terms of the policy, as I mentioned, we are going to have cover the purpose, the scope, the governance, the risk category, and the risk appetite based on the Artificial Intelligence Act. Of course, that is not the whole policy information. There are other considerations that has to be made. For example, over here in the screen, you see in terms of the policy, the integration with other systems and processes on how it's going to be managed in general, that is going to be linked to other processes. Over there, for example, you see in the screen how initiate the activities and link it to what exists in the specific case of a system project. Therefore, this can be considered as a tool that can be implemented in different European Commissional projects that are going to be developing or using artificial intelligence. So again, what happened with these other classes? What happened with the risk category, risk register, risk reporting? That's going to be specified later on because these are part of the tool that was developed. When we talk about the risk architecture, there is specific over here, again, definition that have to be set. That is going to be dependent of the specific implementation organization. So you can use this screen that talk about the different entities that are taking care of the risk management, how and the responsibilities and how the flow of information is happening. For example, that we have the risk board, that is the overall main component that could partially take the decisions, but we have executive committees, management commitment, and divisional management that could be at the same time extracting the information, accumulating information, and analyzing the information of the risk component. Again, if you need further information, you can just stop the screen or go to the public access of the information that is shared. When we talk about the risk strategy, okay, we have to fulfill the requirements, but that doesn't mean that we have to take care of all the requirements for the artificial intelligence, okay? So when we talk about this, over here in the screen, you are seeing the linkage that exists for the different risk management strategies of the RAS approach with the different tools or components that are needed to be taken care of in order to fulfill the RAS approach. For example, we can see that the benchmark test for significance, we're using metric historical records, and for the risk assessment technique, we are going to be using the FMEI. Now, when we talk about the protocol was based on the approach that was previously shown in the ISO 31000 with some modifications. So the main component in the protocol are the AI confirmation, that is basically recognizing what elements are existing of artificial intelligence in the asset that are under evaluation, because it can be more than one. And for that, we use the AI watch classification. So we are able not only to recognize, but classify based on this AI watch classification documentation. When we talk about the risk identification and classification, it's a UML process that helps the user to identify specifically which one of the risk level is involved for my AI asset. When we talk about the AI scope definition, it's accumulation of information that help before going into the management by itself to accumulate the information and see which one of the trustworthy requirements are the most important to be deployed for each one of the specific AI assets that exist in the system. When we have that done, we can jump into the analysis of values that incorporate the user's values. Values are being presented in another presentation, so you can go over there and have a broader understanding of values. But once you have defined which one can be incorporated, depending on the user's need, you can consider them for being implemented, and of course you have to consider for risk management depending on the values that you want to be incorporated. And finally, you have the execution of the risk management process. That is the main ISO 31000 tool screen that I've been showing. That is the continual process that has different tasks. These tasks, of course, are UML based on the type PRM tool that we are showing over here. So the first thing is when we're going to be doing the risk identification, not all the trustworthy requirements are going to be needed. Depending on the classification of risk level of the AI tool that is done in the process by itself, it will be specified which trustworthy requirement you have to put more attention. Incrementally, from the bottom to top, you will need society and environmental well-being. This was settled as a background because of general considerations. It's not required, but we put it at least in this project management. Then incrementally, when you are as a limited risk, you need transparency, technical robustness, and safety. Then when you have high risk, you need accountability, human agency, and oversight. There are other components that are not specified over here, but once it's going to be performed the scope analysis, they can be incorporated. To identify which is the risk level, we also have developed a UML approach to define specifically, depending on the functionalities and the domains, what is recognition based on artificial intelligence at what is the risk level of your AI asset. After that you have defined the intrinsic risk level of the asset, you are going to jump into what is the AI scope and definitions that you can incorporate further perspective of trustworthy AI requirements that were not considered previously. For example, depending on the information that you are providing this UML, you have to be incorporating privacy and data governance for the analysis of this specific asset. So at the end, you will come with a list of what are the specific trustworthy requirements that you need to take in care in the risk management process. Now, let's see. Analysis of values and definitions. This is something that we have previously discussed, and values can have contradictory nature. So you have to specify these values that are going to be incorporated. Values can be translated to norms, and norms can be translated to functionalities. So you could generate a sense of what functionalities you can have incorporated into your artificial intelligence asset. Okay? Now, when we go into the risk management process, this is the general stage that is going to be iterative, and how iterative is going to be defined by the policies that you established in the risk management process. But over here, first you are going to have a layer that is going to establish the context. It's not that it's going to be accumulation of everything, of the information that you gather. This is information not only from the previous ML, but if you have diagrams that are going to be telling you the impact that the artificial intelligence had in the general system, this can be used for have a deeper analysis in general. Then you have the risk analysis and evaluation process. So basically over here you are using the tool FMEI. For doing that, the TAI PRM has come with more than 200 failure modes that can be linked to AI components. And most importantly, these failure modes have been linked to different trustworthy AI elements. So the idea is that if you're going to be using this tool and you have a specific requirement to be careful or have to consider, you don't have to kind of like analyze everything. You have to consider the failures mode that are linked to these trustworthy requirements. Of course, that doesn't mean that you could have all the failures mode for the specific asset, but it gives you an idea of, this list will help you to identify possible risks that you have in your AI asset. Once you have identified and doing an evaluation, that means that at the same time you have come with some metrics on risk level of the asset, you have to define what is going to be done. For that, normally you can use something that's called a heat map or risk matrix. So the idea is at the same time you can link for depending of the risk appetite that is set by the enterprise and at the same time by the European Commission in the Artificial Intelligence Act, what you will be doing with it. So these options can be, you can treat, you can transfer, you can terminate, or you can tolerate. Tolerate is basically what we were talking at the beginning of this course, that at a certain level you are going to tolerate the risk, and you are not going to do any further modifications. But depending on the metrics that you are getting into this risk analysis based on the FMEI, you can also produce treatment over the AI, so that means modification of the functionalities. You can transfer the responsibility to other institutions that is not necessarily available right now. And you can have determination, that means decommission of the AI asset. Then you have to do the update process that is performed by keeping the whole information and together with the monitor and review process, that is going to be the useful tool that you can have in this cycle, that you are going to have a full documentation and the approaches that you have to seek in the following stages. So again, a little bit of what is the FMEI. This is the failure mode and effect analysis, and it's a broadly known component in different domains. Okay, you can extend it by considering the criticality analysis, and is named after that FMECA. Okay, so is this extension allowed to have a deeper analysis when you have some information to analyze some risk or some specific historical metrics. These metrics are not necessarily easy to gather, therefore you can focus only on the FMEI if you have no possibility to obtain some probabilistic values. This is, if you have not, also you can consider that you are going to be performing each one of the both based on a expert judgment or based on data historical record that you have. Now, what is the FMEI a little bit? So FMEI is a bottom-up approach of analysis. When we have an event or a negative impact on any system or users, the way of seeing the process is that we have a problem, we have an issue, we have a damage, or something that negative happened, and we try to analyze, given that occurrence, what was the possible reason of the effect. This was the base of analysis in HAZOP or Hassan, that are well-known mechanisms or techniques, for example, in the chemical industry. When you go in the opposite direction, you analyze possible consequence and see what could be the impact, is what is the FMEI approach is looking for. Okay? Over here in this presentation, we are not going to be showing the 200 possible failure mode, but again, I'm going to be showing the linkage to where you can access the tool, and therefore you will have access to this list of 200 failure modes of AI assets. Now, a little bit of the KPIs. It's important to consider that KPIs are used for keeping track the state of the risk management process, and also to define how trustful at the end will be the AI asset. We have come with 3 different clusters of metrics that are related to the FMEI, that is the one that is with the number 1, and you can see some examples in the screen. In the second, are independent but to the FMEI approach, but are still can be linked to ethical considerations. And the last one is relevant to AI implementations. For example, we have the typical metrics of F1 scores, or accuracy, precision, or other metrics that are used independent of the AI asset that we are talking. For example, for machine learning components are different metrics that can be used to track the AI assets. Over here in the screen, you are seeing some exemplification or some definition of these KPIs. And I'm not going to go through all of them. So again, if you want to stop the presentation, I'll read them, there's no problem. But there's different, over here you can see the meaning of each one of these KPIs and how we can relate it to keep track of ethical concepts or ethical states or the risk of the AI elements for the specific domains. Now, let's jump to the TAI PRM tool. This is the last component of this course. So first important is over there in the web page that you are seeing right now, you can access to this tool. This tool as two ways of seeing or improving or analyzing the AI asset, because first, it provides a page that is directly feeding the Altai tool. So you will, in the same page, you will also have or run the Altai tool, and you will be able to link it to the risk management process. A full definition of explanation is in this web page. So please, if you are interested, go on the page and read and the abouts, and the nomenclatures are going to give you information on how each of the different terms that existed. But important, the site is also providing how to run the Altai tool in parallel, but is allowing you have a feedback for us, and can be provided maybe in the future feedback to the European Commission, or how relevant is really the questions of the Altai tool for the specific domains, because there's no discrimination of the domain in the Altai tool. Over here, we are evaluating, depending on the domains, how useful is or is not the Altai tool questionnaires. When you are going to have, again, this is going to be the specific part of the component when you go to My Altais. But if you are going to be performing the TAI PRM, you have to go to My TAI PRM tab on top of the screen. Okay? Over here, it will provide you different linkages, and it's going to go incrementally in the questionnaire. Even though it's based on a UML, the questions are driven in the same way that the UML presented in the deliverable of the assistant project was done. So this is going to be, for example, linking you not only to the different stages of the risk management process, but it's also giving you a page with all the different failures modes that exist. Over here, it's just showing a rough, very specific failure modes, but the real one can be accessed in the link shared in the screen. The other thing, again, is very important because it gives you the nomenclature of everything related to the risk management process. Some additional benefits that has this tool, it keeps track of your risks, generate automatically a report. So once you feed all the information, it's going to give you a risk management report. Okay? And importantly, you can link it to the Altai tool that is included in this link, and therefore it will provide you the accumulated recommendations based on your risk level and your elements or assess different feedbacks that you have provided for the system and the failures mode. Okay? It's going to also be helpful to provide some KPIs that will help you to keep track of the trustworthy elements. And again, something is very important, the last, as I mentioned, that can be linked to the Altai tool. So you can have both tools at the same time, risk assessment and risk management. Thank you very much. This has been the course of Artificial Intelligence and Risk Management. And if you have further questions, you can contact me. Thank you very much.